Welcome back to the deep dive, where we, try to get past all the fluff and right to the good stuff. And today we're diving deep, right into the heart of industrial biotech. We're going to be talking about cell disruption, which, might sound a little destructive, but it's a really crucial
Yes,
process.
it's actually all about getting access, like, how do we unlock all those amazing compounds, enzymes, proteins, all those things that are trapped inside cells?
Right, right. So, like, we're not just talking about blowing stuff up.
No, no, no. It's much more controlled than that.
Okay, so before we get too deep into the specifics, let's set the stage a bit right now. Why is this whole cell disruption thing so important in the first place?
All right, so imagine like you've got this treasure chest, right? And inside there's all this gold, these valuable things, but it's locked, right? The cell is that treasure chest, and what we want, those enzymes, proteins, even DNA, it's all locked inside.
Okay, yeah, I'm with you. So cell disruption is like finding the key, figuring out how to open that treasure chest.
Exactly. We need to get in there to harvest those valuable intracellular products, right? We call it cell lysis or cell breakage. And it's the first step towards purifying and using those amazing molecules.
I see. So it's not just about breaking things, it's about, targeted release.
Absolutely. And this is where it gets really interesting, right? Because not all cells are created equal.
Right. Different cells, different challenges.
Exactly. So like bacteria, they're relatively easy to crack open, but yeast cells, much tougher. You've got plant cells with those rigid walls and mammalian cells. Those are quite fragile.
So one size fits all approach, that's not going to fly here.
Not at all. You have to really consider the specific cell type you're dealing with. And it's not just about the cell, but also the scale of the operation. Are we
Yeah.
in the lab or are we talking industrial scale production? And of course, the sensitivity of the product itself matters too, right? Some of those molecules are really delicate.
I see. It's a real balancing act. Got to be tough enough to break the cell, but gentle enough to keep those precious molecules intact. Our research pointed to like three main categories of methods here. Can you give us like a quick overview?
Sure. Sure. We've got physical methods, chemical methods, and enzymatic methods. Physical methods are, well, kind of brute force, like high pressure homogenization. Basically, you're forcing cells through a tiny space at incredibly high pressure. Like imagine squeezing a watermelon through a straw. It bursts, right?
Oh, okay. A bit intense. What about sonication? What's that all about?
So sonication uses sound waves, high frequency ones, to create these tiny bubbles, cavitation bubbles, that when they collapse near the cells, they basically blast them open.
So sound as a weapon, that's pretty cool. And what about the gentler approaches, the chemical and enzymatic methods?
Right. So chemical methods are more about dissolving or weakening the cell walls, like using detergents or alkaline solutions. And enzymatic methods, they're like using specialized tools, like, imagine a lock and key. Certain enzymes target specific components of the cell wall and break them down precisely.
So each method has its own strength, its own weaknesses.
Exactly. And the trick is to, match the right method to the specific cell and target product.
To get the most bang for your buck, so to speak. And speaking of that, like what's the ideal outcome? What are we aiming for here?
So ideally, you want to release as much of the target product as possible, right? You want a high yield, but at the same time, you don't want to damage it, and you don't want a ton of cellular junk mixed in because that just makes purification harder later on.
Yeah, makes sense. Clean and efficient extraction.
Exactly. Maximum product, minimum mess. So just to sum it up, cell disruption, it's this essential process in industrial biotech. It's the gateway to those amazing intracellular products that we rely on for so many things.
And the takeaway here is that there's no one size fits all approach, right? Choosing the right method, that's key.
Absolutely. And that brings us to, something to ponder. We talked about different cell wall strengths and
Yeah.
different scales of operation. So think about this. How do you think those factors influence the choice between, say, a physical method, like high-pressure homogenization, which requires a lot of energy, versus a more targeted but maybe slower enzymatic approach?
Hmm. That's a great question to leave our listeners with. A lot to chew on there. Thanks for joining us on this deep dive into the world of cell disruption. We'll see you next time on the deep dive.
See you next time.